Hello, let's do one up. Puzzle 234. It's an 8x8 today. So the way this puzzle works is each row and column has been potentially split by bold borders. And it splits it into segments. A segment of length n has the digits 1 through n exactly once each. So we need 1 through 5 in this segment and 1 through 3 in this one. Horizontally, it works the same. We need 1 through 5 here, 1 through 3 here. And then additionally, if a row or column has no bold borders, like this one here, it has all of 1 through 8. All right, I'm going to get started. I saw some gimmies. There's a 1 here, there's a 1 here, because of the horizontal and vertical and horizontal segments. This needs a 2. This can't be the 2. So the 2 goes there and the 3 goes there. All right, there were some other gimmies, I think. Wait, we got these 2 1s. Were there other gimmies? Yeah, here, this is 2 cells. That's 1 and 2. We need 1 and 2 here. All right, I'm going to scan each short segment just to make sure I'm not missing anything obvious. We need 1 and 3 here. 1 through 4 here. Okay, 4 can still be in one of these 2. This can't be 1 or 2. This is 3, 4 only. I don't think that helps me. Okay. Worth keeping in mind. 1, 2 here, 1, 2 here. This 2 looks down. That's 1, that's 2. I need quite a bit in this column. I don't see anything really special there. 1, 2, and 3 here. Okay. How about vertically? 1 and 3 here. This is probably one of the hardest of the week. I think tomorrow might be harder. All right, so that's all the gimmies. There might be gimmies in the high digits though. So 8 is the biggest digit because we're an 8x8. But 8 can only go in rows and columns that are 8 long. And so the 8s are going to end up at the intersection of those rows and columns. So what I'm going to do is going to mark everywhere that 8 can go. So normally an 8 could go here, but there's a 2 sitting there. So this can't be 8. 8 could go here. This can't be. 8 could go here. This can't be, this can't be, this can't be. So we're expecting 2 more 8s in this puzzle. There should be 1 more row that needs 8s. Or sorry, we're expecting 3 8s in this puzzle because there's 3 columns. So this row needs an 8. It could come from here or here or here. And then this row needs an 8 from here or here. This is filled with a 4, so it can't be 8. So we can't resolve those 8s yet, but sometimes adding 7 into the mix will help. We got to be careful though, because rows like this segment can also have a 7. So in this row, let's see, the column, where's the 7 column? The 7 column's here, so this row doesn't actually get it. So the 7 joins the 8. So this is our kind of our first deduction, which is a hidden 7-8 pair. What do I mean by that? Well, this row needs a 7 and it needs an 8. And these 2 columns are the only 2 columns that can provide a 7 or an 8 at all. Can't put a 7-8 here, can't put a 7-8 here, can't put a 7-8 here. So if we need 2 7-8s, we need 2 cells for that. These are the only 2 cells that can. That means they push out anything else that we thought could be in there. So that leaves behind, that removes 4, 5, and 6 from these. These already couldn't have been 4, but it removes 5 and 6 from them. So maybe the question we want to ask is, where does 6 go in the row now? Because it can't go in these 2 cells. And 6 is pretty big. So this is only 5 long, so we can't put a 6 there. This is only 4 long. And so actually we know this is the 4, because it can't be 5 or 6. And then this is 6 long. So actually the column lengths are telling us what the digits are. We get the 4, 5, and 6. That's not always true, but it is in certain cases, and that can be a nice shortcut if you notice it. Okay, so we got the 4, 5, 6 placed in this row. Does that help us with any immediate deductions? Not that I can tell. It might, but not that I can tell. So what I'm going to do is I'm going to continue looking at 7s. This row is going to need a 7. It could come from here, or here, or here. Oh, this 7 length already has a 7 in it, so we don't even have to worry about it. This row already has a 7, so this is the last row that would need a 7, here or here. So unfortunately, we can't resolve the 7s, but we do have them marked now, and that's it. We need 3 more 7s. We need 3 8s and 3 7s. Now I'm going to think about 6s, because I still don't think the small digits have been helped. So this row already has a 6 because it's down to the 7, 8. This row is going to need a 6, and it's going to come from anywhere that we can get a 7, because we don't have any 6s placed except this one. Or it could come from here, which is the 7 length segment. This is 5 length. Okay, we need a 6 from here, here, or here. Can't be from here. There's already a 6. Can't be from here. There's a 7 sitting there. So don't get confused. These overlap, but they're not a hidden pair because there's 3 cells that can have the 6 and the 8. Now down here, down here we have another 7-8 hidden pair, which I didn't notice. So just to double check, this can't be 7-8. This can't be 7-8. This can't be 7 or 8. Can't be 7 because of the 7 here, and it can't be 8 because it's a 7 length segment. This can't be 7-8. Can't be 7-8 because all because of segment links. So this is another hidden 7-8. So I guess the question is, where does the 6 come from first? That can't be 6. That can't be 6. I think it's, yeah, it's only going to be here. There's already a 6 in this column. So we can place the 6. Now the question is, where does the 5 come from? 5 could come from either of these, actually. We're left with 1, 2, 3, 5. This can't be 1 or 2. This is 3 or 5. Can't be 2, 1, 3, 5. 1 or 2, 1 or 3. I don't think this resolves. But we did get our 6. That means this can't be 6. This row is going to need a 6. I wonder where it comes from. Could come from here. That's 2 length. Could come from here. That has a 6. That's 2 length. That's 5 length. Okay. So we do need quite a few 6s still. We need 3 6s. You can kind of see the pattern there. Okay. Do I go down to 5 now? I feel like, okay, I got this 6. We know this is hidden 7-8. This is, okay, because this is a hidden 7-8 and this is hidden 7-8, these can only be 7-8. That makes a naked 7-8 pair here. Because we know that these have to be different digits because of the column, and we know that they must be a 7 or an 8 each. So this is a 7-8 naked pair, removing 7 and 8 from the rest of the column. Doesn't immediately do anything, but definitely nice to have that marked. So now we're left with this 7-8 pair. Oh yeah, okay, that's still not quite helpful. I think I might have to move down to 5s now. All right. 5 could be here or here. That's 4 length. These are 1, 2. Hold on. Let's stop doing 5s for a second. This 4 here actually did do something because this segment needs to be 1, 2, 3 now, and this sees a 2 and a 3. So that's our 1, and now we're left with 2, 3 here, which is not resolved. So there's 4 digits left here. 4, 5, 6, 7. So this is only 5, 6 because it can't be 4 or 7. Same thing. Don't think it's the same thing here. Okay. So 5 can go here. 5. Let's just do this. 5 can go here, or here, or here. This row needs a 5. Can come from here. This already has a 5. It needs a 4. Yeah, it doesn't help. Already has a 5. That can't be 5. This could be 5. Don't need a 5 there. This row needs a 5. Could come from here, not here. From here. 4 length. From here. This could have a 5. This could have a 5. So I think 5s aren't going to be super helpful here. This row needs a 5. Remember, this is a hidden 7-8. So this can't be 5. That can't be 5. 5 comes from here or here. Okay, now this row needs a 5. Here, or here, or here. 5 is way too open. 5 could come from here, or here, or here. And we're getting to the point where you have too many things marked. So I think probably what we're going to need to do is think about the low digits and get some pairs out of the low digits. So the only things not marked are 1, 2, 3, 4. So let's think about this. This needs to have 1, 3. This is 1, 2. Let's mark all the 1, 2s. 1, 2, 1, 2. So this is a 1, 2 pair here. So the remaining digits are 3, 4 to get placed. We know that one of these two is a 4. Doesn't seem to help me. 1, 2, 3, 1, 1, 3. 1, 2 here. Ah, yeah, so this is 1, 3, this is 1, 2, 3. So we have a 1, 2, 3 triple in this column, right? So there's a hidden 4, 5 basically here. The 4 5s like this. My markings are horrible today. That's the problem with the top-down strategy of marking the one digit at a time, is it's hard to know which of your cells are fully marked, which ones aren't. Here we need 1, 3 as well. Oh, this can't be 1 or 2. So this is our 3, this is our 1. There we go. That's 2 and 1. 2 makes that not a 2. That means this is 2 for the row, which gives a 1, 2, and 1. That gives the 3 and the 1, giving the 2 and the 1. Okay, at least those are filled now. 1, 3 pairs here. 4, 5. Ah, the 1 looks down, giving us 3 and 1. There we go. Yeah, so the low digits did have stuff to do. 4, 5. We know this is 7, 8, so this is 3, 5. Ah, and this 3 looks down, so that's 5 and that's 3 for the row. So this 5 removes 5 from here. What's left here? 4, 5? So this is actually a 4, 5 pair here, meaning these can't be 5s. So we're left with 3, 6. I need 2, 4, 5 across here. This can't be 4, this can't be 4, so this is our 4. So this is 2, 5, and this is 2, 5. 3, 6, 4, 5, 4, 5. This digit can be finished. This is a 4. That gives us 5 and 4 and 5. And 4. Okay, I'm getting there. My markings are getting in my way at this point. I need 2, 3, 4 across here. So this is not 2 or 4, so this has to be 3. And this is not 4 either, so this is a 4, this is the 2. 2 looks down, giving us 5 and 2. So I have 1, 2, 3, 4 across here. We need 5, 6, 7, 8. 5, 6, 7, 8 are already marked. So this can only be 5 out of those. It's a 5 length segment. So that's our 5. That's not 5 anymore. All right, here we need 1 and 2. I actually don't know the order of those yet. I probably will soon. Here I need 2 and 3. Here, this can't be 1. Ah, so where's 1 in this segment? It's here. That's 2. That's 3. That's 2. So this is our 3, giving us the 6 and the 3. Oops, 6 and 3 here. 6, remove 6 from these. We have 1, 2, 3, 4. So 5, 7, 8 is correct here. Okay, I need a 1 in this segment. Can't be 1, this can't be 1, and this can't be 1. So the 1 ends up here. Oh, this 5 has been sitting there. That's 8, and that's 6 now. That's our 7 and our 8. That's our 7 and 8. This can't be 6 or 8, so this is 7. We get our 5, I assume, and our 6. All right, managed to do it despite the horrible marking today. I need another approach for these larger, more difficult puzzles. I think probably once the large digits start failing, I need to like erase them and start doing the small digits again. Or maybe I need to pay a bit more attention to the small digits before I start doing the large digits. It's hard to know, because before you mark the large digits, you can't know like what you're going to find. We did find some hidden pairs and stuff. So kind of tough scanning. And also just a lack of notation ability. Like if I was doing this in Sudoku Pad, I would have a very different notation scheme, I think, because I could use corner and center marks and I could color. So anyway, with the limited interface, I think I did okay. But yeah, cool. Let me know how you did.